Hello everyone, welcome to lecture number 7. In lecture number 7 onward, we will be going through the design of flat slab. As you remember, in earlier 6 lectures, we have discussed all the design methodology of continuous beam as well as design problem we have discussed. So it is advised to all of you, whenever you going through these video lectures, maybe from lecture number 7 onward, you are advised to be ready with a copy of IS 456 so that you will can better understand the various clauses and design methodology which we will be adopting in the design of flat slab. Then it will be very easy and comfortable for all of you to understand all the concepts of the design methodology as well as design problem, design concept, everything. So this is a topic that is a design of flat slabs. In your DCS 1, we have gone through one-way slab, two-way slab. So both the design we have discussed in detail. Now we will be switching over to flat slab. Now question is, what is a flat slab? And in this figure you will be able to see that this is a diagram, a sketch of a flat slab. You may be able to see in this photograph that only columns are there and no beam is visible. So that means if there is no beam to take care of the load of the slab, then that type of slab without the beams will be called as flat slab. So flat slab will be supported on various number of columns which you are able to see here. So let us try to understand all the things. Okay, so RCC slab, now flat slab. As already in the previous slide I have told you that this slab is free from any type of beams. So let us first of all try to understand, let us recall one-way slab and two-way slab. But what is the basic difference between one-way slab and two-way slab? Then we will be able to understand what is flat slab. Now this is the picture of a one-way slab. Now this is a slab section which is supported by beams, and these beams are supported by columns. So in this figure or in this picture you are able to see that there are two beams are there, and these beams are supported on 4 number of columns, and you may be clearly see here that beams are only in one direction. So that means in this direction beams are there, in this direction there is no beam. So if you say we can say that along y-axis there are the beams, but along axis there is no beam, and slab is directly supported on these beams. So this is one-way slab. Now what is the guideline when how you will decide whether it is one-way slab or two-way slab? So first of all we have to check whether longer span by shorter span ratio is greater than or equal to 2. If so, then it is a one-way slab. Main steel will be provided along shorter span, only along one direction main steel will be provided. Distribution steel to take care all of the temperature stresses, shrinkage stresses, etc. So distribution steel is provided along longer span. So one thing is very much clear here. In case of one-way slab, main steel is along the shorter direction, shorter span, and other thing is main steel is only in one direction. because bending is prominently along one direction, or you can say bending is such that the slab will getting deflecting prominently along one direction, that is along longer span. So bending along one direction is predominant. Accordingly, steel required will be lesser and thickness will be definitely more. So one-way slab thickness will be required will be more. Now two-way slab. Now, this is the picture of two-way slab. Now you can see here that this two-way slab is also supported on beams, but beams are along X as well as Y direction. So that means along all the directions beams are there and beams are supported on column. Ultimately, all the beams are carrying the load of the slab. So this is two-way slab spanning in two directions. So here again, longer span by shorter span should be less than 2, then it is a two-way slab. Main steel along both the spans, longer span as well as shorter span. Bending along both the direction, that means bending along shorter span as well as longer span, they both will be considerable. Steel required will be more because bending is more, so steel will be more. Thickness is comparatively less as compared to one-way slab. So these are the two types of slabs which we have already studied and designed in the previous class. Now to recall, I have discussed all these things. Now let us understand what is basically a flat slab, what are the requirements of the flat slab. So when flat slab is basically required, when we have to go from one-way or two-way slab to flat slab. So here in this picture, figure number 1 or picture number 1, you can see a view of a flat slab. Now this is a flat slab and the flat slab is supported directly on columns. So here 4 number of columns are shown. No beam is there. So again I am repeating, flat slab is basically a beamless slab. Now these drop panel, column capital, we will be going through in detail in the coming lectures. Now requirement, what is the requirement? When no beams are required due to any reason, due to aesthetic reason, due to architecture point of view, if you have to design a slab in such that you are not willing to provide any beam, so no beam to basically to increase the head space. You are very much clear when there is a multi-story building, so number of you can say office blocks you have to provide and your emphasis is on to increase the head space, or it may be any industrial building where you want that beam should not be there, it should be clear slab you require. Aesthetic requirement is there, definitely visibility will be more. Better interior design you can do with the space available. So these type of slabs are generally provided in case of industrial structures. You may have seen in parking garages, high-rise buildings, because more space is required. So ultimately, if more space is required, you may try or you may have the possibility to decide that no beam should be there below the slab. Basically, you will find these type of slabs in case of banquet halls where head space or space requirement is quite high. Now this is a simple cross section of the flat slab. You can see this is a portion of a flat slab. You can say it is a panel of a flat slab and these are the 4 columns are provided, and on column there are drops or drop panels are there. So it will be looking like this. This is a slab and this slab is directly supported by columns. Now there may be various type of flat slabs. Now you are easily understand the concept that this is a flat slab and directly supported on column. Now column is directly under the slab. That means there is no drop or no column head. That means there is no projected portion on the column. Now you can understand this is a column and this is column capital. That means some portion of the column is broadened. Later on we will discuss in detail. Then above column capital there is drop panel. So what is the purpose of these drop panel column capital? You know that if we don't provide this drop panel or column capital, then this column size is very lesser as compared to slab size. So there may be punching failure. That means column can get punctured, it can puncture the slab. So to avoid that, we have to increase the upper area of the column by different ways. Now this may be one type of the flat slab where no drop is provided, no column head is provided. Now in figure number 4, you can easily understand that this is a slab, this is column, and on column area has been broadened with drop but no column head. Now no column capital column head is provided, only drop is provided, column drop is provided. That means it will be just like a panel, it is a drop panel. In this fifth figure, you can see that here this is slanted column portion. That means there is no drop but column head is there. Now this is column head and above column head there is no drop. So there may be possibility you can design it without drop and without column head, with drop without column head, without drop with column head, or sixth may be with drop as well as with column head. So that depends upon the requirement which you will be able to understand when you go through the design process. So here we can define flat slab. Flat slab can be defined as a RCC slab with or without drops, supported generally without beams by columns with or without flared column head. So this one is flared column head. So there may be flared column head or may not, you can provide. And for the design methodology of the flat slab, we have to refer clause number 31 in case of IS 456. You go through. That's why I have advised you, when you are going through the video lecture, you are watching the video, then you must be in hand with IS 456, copy of IS 456, so you can understand it more effectively. Now RCC slab, flat slab design methodology as per IS 456 guidelines. Method of analysis and design. Now what is the method of analysis as well as method of design which is recommended by IS 456? Let us go through some of the guidelines today. For this we have to refer clause number 31.3.1 of IS 456. So IS code is recommending two methods for the design and analysis of the flat slab. One is direct design method, which is mentioned in clause number 31.4, and second one is equivalent frame method, which is clearly explained in IS 456 in clause number 31.5. Now few definitions which we have to understand clearly so that we can design a flat slab effectively without any confusion. So first one is slab panel. Now in first figure we have gone through that there may be a flat slab. So flat slab may be having number of spans, not single span, number of spans, and there may be number of columns. So first of all we have to understand what is the meaning of slab panel. So slab panel as defined in clause number 31.1c, slab panel is part of the slab. Now it is not the whole slab, it is part of the slab bounded on each of its four sides by the center line of the column. So that means if there are 20 number of columns, or you may say along one span side there may be 5 number of columns, 4 number of columns. So when you draw the center line, that means you draw a line joining the center to center of all the columns, then the one slab portion which is bounded by four sides by the center line of the column. So let us consider there are 4 columns. So when you join 4 lines from center to center of the columns, so then that will become a one panel. You can go through IS 456 if you have any doubt. Second one is to design flat slab as per IS code method. So IS code is suggesting a methodology where the whole flat slab will be divided into panels, and then panel will be divided into column strip as well as middle strip. So let us understand column strip. So let us consider there is a one panel. Suppose this is one panel and this one is center to center is L2, and if this is L1. Now what we have to do, we have to divide this panel into strips. So a design strip having a width of 0.25 L2. L2 is one span length is L2, another span length is L1. So when you divide L2 by 4, that is 0.25 L2, but not greater than 0.25 L1 on each side of the column center line. Now suppose here you have one column, here you have another column, there may be another column, and there may be the another column. So center to center from these two columns is L2 and center to center of these columns is L1. So when you have to show or when you have to point out that column strip, so it will be a strip. Strip mean just like if this is a panel, then this will be one strip. So this portion will be one strip. Now what will be the width? This will be the width of the strip. So code is saying that design strip, column strip having design strip having a width of 0.25 L2 but not greater than 0.25 L1 on each side of the column center line. Now this is column center line, this is column center line. Along each side of the column center line, where L1 is the span in the direction movements are being determined. Now another point you have to be clear here yourself without any doubt that a flat slab is extended type of two-way slab. That means we have to calculate bending moment along both the spans. So column strip, let me explain you more clearly. A design strip having a width of 0.25 L2 but not greater than 0.25 L1 on each side of the column center line. Now this is column center line, so that means this portion and there will be another. So this will be the column strip. Measured center to center of supports, and L2 is the span transverse. So if this is L2, then L1 is the this side. Measured center to center support, and this same thing is clearly mentioned in clause number 31.1.1a. Then middle strip. Now when you decide a column strip, now if we see here in this figure, so there will also another column strip. So then this strip will be middle strip. So it is saying a design strip which is bound in both of its sides by column strips, that is a middle strip. 31.1.1b you can refer. So I recommend you all of you to go through the IS 456 and try to understand all the definitions carefully. In the next class we will understand by taking a section of a flat slab panel, that means how to label and how to measure column strip as well as middle strip. Thank you.